We're going to do several different things today to get us started. We're going to look at graphing a little bit and how that works. So here we go. First off, when you guys think about whether or not things are bigger than or less than, you guys can picture that in your minds. But if I add a variable to the mix, and I have just jumped over to page 60, and I ask you to solve and graph, the process isn't that difficult. It just takes a little bit of practice. Okay? So I'm going to do a few different examples for you. In example 1, my first example, my example A, is going to look like this. 3x plus 16 is less than 7. Okay, none of you would be nervous if it was equals to, but maybe that less than makes you nervous, but you don't need to be. You do the same exact steps that you've done up to this point, adding and subtracting where necessary. And you should end up with, that should be a 16. That should be a 16, sorry. Adding, subtracting where necessary. So if I do this, I now have 3x is less than a negative 9, right? Mm-hmm. Divide or multiply where necessary. In this case, we're dividing. Now, this coefficient is positive, which means the sign does not flip. When you divide by or multiply a negative number, the less than or greater than, less than, equal to, greater than, equal to symbol flips. Okay, in this case it wasn't negative, so we don't flip the symbol and we still have this. That means x can be anything smaller than a negative 3. And when they say graph it, literally a handful of numbers will do the trick. Okay? Less than is an open circle, meaning every single number smaller than a negative 3, but not including a negative 3. And then you shade heading to the left. Less than, shade heading to the left. So less thans are always open circles, as are greater than. Open circles. We'll learn a bit about less than, equal to here shortly as well. Another example. 11 minus 3 halves r is greater than a negative 4. Subtract 11, and you should have negative 3 halves r is greater than negative 15. The coefficient is a fraction, so we can't divide by a fraction, but we can multiply it by its reciprocal. Notice it's a negative. So when I multiply by that negative 2/3, multiply by negative 2/3, r is now less than whatever the result of this is. R is less than whatever the result. After you reduce, you have a 10, greater than 10. 10, 11, 12. I'm not building a huge graph. Greater than 10. Does not include 10, anything greater than 10. Okay? Wait a minute, less than. Yeah. Shoot! Mrs. Myers, 10. Oh, 9, 8. Less than. Sorry. Thank you for yelling at me, I appreciate it. Sorry. Flip the sign, less than 10. See, I showed you a great example of what not to do. I'm not seeing any less than equal to's, greater than equal to's in this section. I guess they're going to introduce those later, but just for information, less than equal to's and greater than equal to's would be closed circles because they would include that item. Like if this said R is less than or equal to, that would mean the 10 is a possibility as part of the choices. That's what that means. Okay? All right. Those are some example ones. Now, to quickly check whether or not this is true, like if you kind of get mixed up with this when to flip or not to flip, fill in a number that would help you test. Like maybe in this number, anything less than -3. So maybe you might say -1. Or maybe you might say 0. Because let's face it, 0 is easy to test here. You might say 3 times 0 plus 16 minus 16 minus 16, -9. X is less than, 0 wouldn't work because it's not less than. So -4. -12 added to a -16, is that true? Yes. 0, of course, wouldn't work. I don't know why I said that, guys. 0's up here. All right. You can test it by finding a number that satisfies what you believe to be true and testing it back in the original. All right. You are going to find no solutions also, as well as all real numbers. Okay, you're going to find no solutions in all real numbers, and that's what example 2 introduces to us. A is going to be a no solution, and I'm going to show that to you here real quick. The opposite of the difference of 10 and R is less than the difference of R and 15. If you remember from Algebra 1, this negative preceding the two terms within parentheses forces you to flip the sign of both of those pieces, making it a -10 plus R less than R minus 15. You might even be able to visually say R minus 10 is less than R minus 15. Well, that doesn't make any sense. And if you don't see it yet, try to collect your R's on one side. -10 is less than -15. Is that true? As a matter of fact, it's not. -10 is actually greater than 15. So this statement, after you've solved it, is false. Just like that thing that said integers. You think you have a solution, but the solution that you found is false. Okay? There are several samples of that. There are several of those in the homework here and there. I shouldn't say several, there's a couple here and there. That's a no solution. There's all real number situations as well. And here we have it. 3 times 4z minus 1 is greater than 2 times 6z minus 5. This one's going to seem a little bit tricky. 12z minus 4 is greater than 12z, 3, Mrs. Myers, minus 10. Try and collect your z's and you're going to find that they cancel each other out. -3 is greater than -10. Is that true or false? -3 is greater than -10. So if you get a true inequality and your variables have disappeared, then it doesn't matter what you plug in for these variables because all real numbers inserted here will continue to make that a true statement. So your answer is going to be all. If you're asked to graph it, 0, 1, -1, it is everything. So to graph everything, Something that simple will do the trick. So when they ask you to graph, there's your solution set. You might see something that looks like that in the back of the book as well. That's all. I would like you at this time to turn with me to page 63 because I am going to do 5 examples from the homework. Starting with number 21. Starting with number 21. 21 says, solve. This is bigger, but it is not any more difficult. It just takes a little more work. K minus 3 times the difference of 2 and 4k is less than 7 minus 8k minus 9 plus k. This is a perfect example of a place where you can easily flub up. Okay? I can find ways to flub up all the time, but this one here kind of takes the cake. First thing you're going to want to do is distribute anything that precedes the parentheses into the parentheses, which gives me k minus 6 plus 12k. Everybody seeing what I have on the left? And we'll simplify that here shortly. You might be saying to yourself, well, there's nothing to do here, so it's just k minus 8k minus 9 plus k, but that's not true. So guys, if I could do like a big warning flashing red light, I would put it right here. What this literally means is that negative has to apply to all of these things.
Chandler brought Roman to the office, please.
And that's because what's being subtracted is all of this stuff. We're removing 8k, we're removing a negative 9, and we're removing a positive k. Okay? So it becomes 7 minus 8k plus 9 minus k. So it looks like I have 13k minus 6 on the left and 16 minus 9k on the right, if I performed my arithmetic correctly. So once you've done all the distributing, it's probably not too big of a deal. I'm going to move my k's all to the left, and I'm going to do it all in one line if you don't mind. And I'm going to move my numbers all to the right, which gives me 22k is less than 22? Wow, okay. Remember the rule, if this is a negative, if it's you're dividing by or multiplying by a negative, you flip the sign. This isn't. So you're going to simply divide and the sign will not change. K is less than 1. Okay? 1, 0, negative 1. It doesn't say to graph. I'm just doing it so you can see it. So if it doesn't say to graph, you don't need to. That's all that is. 23. Four times y plus 2 minus 9y. Make sure you're copying these with me. You're going to need them. All of this is greater than all of that. Start distributing and simplifying where you can. Negative 3 over those two things there. Am I losing anybody in this? I'm trying not to go too slow or too fast. 4y plus 8 minus 9y. Well, that'll simplify nicely. Y minus 6y minus 3 minus 1. 4y and negative 9y. So it's a negative 5y. And this will be negative 5y minus 4. Many of you might be saying, uh-oh, something's going to be wrong here. Well, but will it be an all or will it be a no solution? 8 is greater than negative 4. Is that true or false? True. Always true, therefore your answer is all. Because there is never a situation where that will not be true. And if I made that a 1, it would all still be true, no matter what I change the y value to. Okay, that's 23. All right, 25, 27, and 29. Tell whether these are true for real numbers. If not, show why it's false. If A is less than B, then A minus C must be less than B minus C. That looks a whole lot like a property y'all just learned, or at least similar to it. Looks like the addition property. But they're subtracting, so let's look at that. Give me a number for A that is less than whatever number you choose for B. 5 and 7, that's too much. How about 1 and 2? I can't count that high. So A and B. Give me a number for C. How about 3? They don't specify, but I'm going to use 3. So 1 is less than 2. 1 minus, what'd she say? 3 is less than 2 minus 3. Let's see that. Is this a negative? Nope. 1 minus 3 is a negative 2. 2 minus 3 is a negative 1. Is that true? Yep. I'm pretty sure no matter what you do, you're going to find that that statement is true. 27. This is tricky. And some of you might already see why it's false, but I'm going to show it to you anyway. So if A is less than B, then A squared must also be less than B squared. Remember, squaring a number makes it positive, right? I'm going to continue to use these, A and B. 1 is less than 2. 1 squared is less than 2 squared. Oh, it looks like it's true. 1 is less than 4. Looks like that's true. Are there any examples when that won't be true? Negatives. Very good. Very good. So you can't always assume that your positive answer or that your positive samples means it's always true. This is an example. Negative 1 is less than 0. Negative 1 squared is not less than 0 squared. That is an example when this scenario is false. 29, here's the last one. And you've got to build it too. If A is less than B and C is less than D, so I'm going to do A is 1, B is 2, C is 3, D is 4. And you could test negatives if you wish as well. If this is true and this is true, which I've already made with these numbers, then A minus C must continue to be less than B minus D. A is 1, C is 3, B is 2, D is 4. What? Awesome, I'm doing number 30. A plus C, B plus D. Yeah, 30 is a little different. So 4 is less than 6. That's true. If you try negatives, I guarantee you're going to find that one to be true as well. Negatives, you always want to concern yourself with, particularly when you're squaring, when you're dividing, when you're subtracting, because negatives affect that really, really clearly. I mean, not that it doesn't affect it here, but oftentimes I'm finding that if I just test positives in